Dear audience, welcome back. Today we are going to learn the integral of cos mx with respect to x. The integral of cos mx with respect to x is sin mx by m plus c, where c is the integral constant. Let's prove it. Here the right side is sin mx by m plus c, so I write it here and differentiate it with respect to x. That means d dx sin mx by m plus c. Here the derivative of sin mx is the m cos mx, and in place of m I write it m here, and since c is the constant term, so the derivative of c with respect to x will be the 0, so I put nothing on the right side for it. From the careful observation you will find that these m, that means upper m, and the down m will be cancelled each other. So the remaining part is here on the right side is cos mx. So putting this cos mx on the left side and the expressions of the left side on the right side, we get this. That means cos mx, this cos mx comes to the right side, and this d dx sin mx by m plus c, that means this expression which is on the left side comes to the right side. So now taking the integration with respect to x, we get this. That means here I put here this integration sign and dx. Since I am going to find out the integral of the function with respect to x, that's why I put here dx. And similarly on the right side I put the integration dx, and other part I put other parts without any kind of change. And if you notify on the right side, you will find that this integration dx and the derivative symbol dx will be cancelled each other, because integration dx is the antiderivative of d dx. So the remaining part is there sin mx by m plus c. So putting it on the right side, and we get this. And here I put the left side without any kind of change, and that means ultimately we find that the integration cos mx dx is equal to sin mx by m plus c. That means the integral of cos mx with respect to x is the sin mx by m plus c, where c is the integral constant. Let's have a look on some problems relating with this standard integral. Here in the first problem we find that integral, we have to determine the integral of cos 3x with respect to x. If we uh, compare this this expression, that means function cos 3x with the cos mx, we'll find that here the m means 3. So on the right side we'll write it, we'll draw the horizontal line segment first, then um, above this horizontal line we put the sin mx, because here cos mx becomes the sin mx, so we put here cos of 3x becomes the sin 3x. And below we should put the value of m. Here value of m is the 3, so I put here, and plus c, where c is the integral constant. Similarly in this integral we'll find that m means minus 3, so here cos minus 3x will be the sin minus 3x, and in place of m we put here minus 3, because the value of m is minus 3, and plus c, where c is the integral constant. Here the plus and minus becomes the minus, and in place of 3 I put it 3, and sin minus 3x, sin minus 3x. Again, according to the formula we know that sin minus theta equals minus sin theta, so that minus and this minus will be vanished. That means it will be the plus, then the remaining part is sin thrice x, and here plus 3, and in place of plus c I put it here plus c. So integral of cos minus 3x with respect to x is the sin thrice x by 3 plus c. Now the question number 3. Here the value of m is the minus 2 by 3. So the cos minus 2x by 3 will be the sine minus 2x by 3, and by m means here minus 2 by 3. Here plus c is the integral constant. Now I put here sine minus 2x by 3, and here this minus and this plus becomes the minus, and 2 by 3 becomes the 3 by 2, and in place of plus c I put here plus c. So this is the integral of the cos minus 2x by 3 with respect to x. Dear students, let's have a look on some more problems, and which you will do or which you will solve those problems in your home and write the answer in the comment sections. Dear audience, I hope that you could understand the today's lesson. Again, I will come along with a new video tutorial. Till then, goodbye.